Boys and girls, from homework number 3, worksheet 10E. We're going to do number 2 as an example. If sine of 34 equal to P, determine the following in terms of P. Right, this kind of a question is not about rotation of the arm. We are not given information where we can easily situate the arm in a specific quadrant. This is about a right-angled triangle or square identities. Now let's do it as an example. Then you're going to tackle question 3 and 4 very easy.
Right, from this right-angled triangle, we are given the sine of 34. Right, we're going to make sure that this angle 34 is right there in the right-angled triangle, 34 degrees. Remember, these two angles are complementary. Now, or by sum of angles of triangle, that angle is 56 degrees. We're going to make sure that we find all the sides of these angles, especially these acute angles, because they're going to help us to solve problems. Right, we are given the sine of an angle. Remember, the definition of the ratio of a sine of an angle is opposite side divided by hypotenuse side. Now, what is the opposite of 34? It is P. This is P over 1. It is P, and then the hypotenuse is 1. Now, we're going to find the size of this unknown side in terms of P by using the theorem of Pythagoras. Using the theorem of Pythagoras, you know the square of the hypotenuse is equal to the sum of the squares of the other two sides. Then at the end, this side will be the square root of 1 minus P squared from the theorem of Pythagoras. Right, now the first question says find 2.1, find the sine of 146. Now what we're going to do is to reduce this angle until one of these two angles is formed, and we can easily find the ratio. Now let's continue. By reduction formula, 146 minus 34 degrees is 146. Right, now by reduction formula, in which quadrant is 180 minus 36? Is in the second quadrant. Now, is this function positive or negative? It is positive. Positive, the sine of the acute angle. Now, in that triangle, we have 34. Now we can find the sine of 34. The sine of 34 is opposite divided by hypotenuse, which is P. The answer is P. So it means the sine of 146 degrees is equal to P. Now, the second question, 2.2. We are given the cos of 56 degrees. Now, in that right angle triangle, already we have 56 degrees. There's no need for us to reduce this. We have that angle there. Then now we're going to talk about the ratio of the cos of an angle, which is adjacent side divided by hypotenuse. The adjacent of angle 56 degrees is P. Then divided by hypotenuse, which is 1. So the answer is P. Now, the last question, 2.3. The tangent of 34 degrees. Right, already we have 34 degrees there. We have 34 degrees. Right, then now, what we're going to do is to find the ratio of the tangent of 34 degrees, which is opposite divided by adjacent. So the tangent is opposite divided by adjacent. The opposite of 34 degrees is P. The answer is P divided by adjacent side is the square root of 1 minus P squared. That's it. Right, let's go furthermore to explain how to use square identities. let me show you by example. In the very same problem, let's say they ask a question about the cos of 34 degrees. Right, I'm going to explain this. We can use square identities because already we are given the sine of 34 degrees. Remember, the square identities is about the sine and the cos and the same angle. What I mean is this. Remember, the identity state that the cos squared of theta plus the sine squared of theta is equal to 1. Right, we've been using this identity. Right, now because we are given the sine of 34 degrees and then they want the cos of 34 degrees, we can use the square identities because the sine and the cos, they connect with the same angle in this identity. Then we're going to use the advantage of this identity because we are given cos 34 degrees and we know sine 34 degrees. So if we know the same angle in cos and sine in this kind of a problem, we can use square identities. Right, and now the cos of squared 34 degrees plus the sine squared 34 degrees is equal to 1. The knowledge of square identities. Then now we're going to rearrange and then make cos of 34 the subject of the formula. Right, now cos squared 34 degrees is equal to 1 minus sine squared 34 degrees. And then what is sine 34 degrees? It is p. Then we're going to substitute the sine of 34 by p. This is p squared. Then now we're going to remove the square by applying the inverse operation of square root both sides. Then the answer is cos 34 degrees is equal to the square root of 1 minus p squared. If we go straight to the diagram, if you want the cos of 34 degrees, we're going to find the same answer. Right, let me show you. The cos of 34 degrees is adjacent divided by hypotenuse, which is the same answer as this one. So we can use square identities. Good luck, guys. Keep on working hard.